Imagine, just for a second, being a global technology superpower, and suddenly you're completely cut off from the exact hardware you need to survive. For years, the world watched as this complex web of trade blockades and sanctions tightened around China's tech sector. The headlines were everywhere, screaming about a frozen pipeline, an inevitable collapse. And the question on everyone's mind was simple but incredibly daunting. How do you build the future of computing when you're literally locked in the past, completely denied access to the advanced ultraviolet lithography machines required to make modern chips? Well, that exact question was posed directly to the world at a major 2026 conference in Shanghai by He-Ting Bo. She's widely known as Huawei's chip queen. Back in 2019, they were facing what they officially called extreme survival mode. But, she didn't panic. Instead, she activated a $400 million backup lifeline. It was this top-secret mission her engineers had been quietly refining for years. The world really thought the story was over, but it turns out it was just a massive cliffhanger. Welcome to This Explainer. Today, we're diving deep into an absolute engineering masterpiece that doesn't just bypass global competition, it essentially renders the old rules of semiconductor physics completely obsolete. We are going to unpack the dramatic, mysterious, and entirely game-changing breakthrough known as the Tao Revolution. Just look at this headline for a moment from South China Morning Post. This is the news behind today's video. Another deep-seek moment. Huawei milestone alters China trajectory in chip race, analysts. Chip advance marks big step accelerating China's semiconductor self-reliance push and promises leaps in AI computing power. With that said, let's go straight to the intro. The algorithm buries channels that show the truth like mine every single day. The only thing that fights back is you. One like, one subscribe, turn on the bell icon. That's how the truth about China survives on YouTube. Don't let it disappear. Thank you very much. Alright, let's start with section 1, the mission for survival. So to really grasp this massive paradigm shift, we've got to look at the baseline. For decades, right, the gold standard has been Moore's Law, this relentless drive to make physical transistors smaller and smaller. But here's the catch. Moore's Law was already hitting a physical wall. Add in the strict blockades on advanced lithography machines, and Chinese engineers were backed into a corner. They had to find a totally different path forward. So they initiated this massive shift in perspective. Instead of obsessing over geometric size, which is kind of like trying to cram more and more tiny workers on the exact same factory floor, they flipped the script and focused entirely on time. They stopped asking how can we make the parts smaller and started asking how can we redesign the entire factory so the workers just don't have to walk as far. The actual physics behind this strategy is formalized as the Tao scaling law. Now, if you remember your physics, Tao represents the time constant, the speed at which a signal flips, or what engineers call RC delay. By treating physical space and time as two sides of the same coin, well, you realize you don't actually need microscopic components if you can just get the data to travel drastically faster. It's a total game changer, a complete shift from node-driven scaling to just massive system-level efficiency. Moving on to section 2, logic folding, the 3D skyscraper. Okay, so how on earth do you actually execute this temporal scaling in a physical product without those restricted Western lithography machines? The answer is this seriously sci-fi concept called logic folding. It's a 3-step architectural shift, and it is revolutionary. You know how traditional chips are basically flat, two-dimensional grids? Well, logic folding just abandons that planar layout entirely. Instead, they literally fold the logic circuits vertically right at the foundational gate level, stacking active layers into this codependent 3D architecture. Think of it like this. It's like taking a sprawling single-story ranch house where you've got to walk forever just to get from the kitchen to the bedroom, and compressing all of that into a hyper-efficient vertical high-tech skyscraper with a lightning-fast elevator. But to make these 3D skyscrapers actually function at peak performance, you have to connect the floors perfectly, right? The engineers managed to achieve a fine-pitch hybrid bonding of just 1.5 microns. Let me put that into perspective for a second. A single human hair is about 70 microns thick.
So we are talking about millions of vertical copper-to-copper connections perfectly aligned at a mere fraction of a hair's width. This drastically shortens the internal wiring distances, so those signal delays, they practically vanish. And here's the kicker. This isn't just some theoretical white paper dreamed up in a university lab. Not at all. Huawei has quietly and relentlessly battle-tested this entire architecture across hundreds of real-world chips over the last 6 years. It is a proven reality, already operating in the hands of millions of people. Which brings us to Section 3, Proof, the Kirin 2026. To truly measure the weight of this paradigm shift, we've got to look at the hard data behind their flagship consumer proof point, the highly anticipated Kirin 2026, which is designed to power the Huawei Mate 90 series. Now, using only mature, older generation DUV machines, equipment that China already controls, logic folding achieved a staggering 53% increase in transistor density in just a single generation. It jumped from 155 up to 238 million transistors per square millimeter. Theoretically, this leap puts them exactly on par with TSMC's 3nm and Intel's 18A nodes, entirely bypassing the need new EUV lithography equipment. Plus, because the wiring paths in this 3D skyscraper are so much shorter, you get significantly less resistance. This structural reconfiguration yields a massive 41% energy efficiency alongside a 13% bump in operating frequencies, aiming for an incredibly impressive 3.1 GHz. I mean, that is optimization on a completely unprecedented scale. Let's look at the bigger picture in Section 4, System as One Chip. Because the true ambition of the Tau scaling law goes way beyond just a single smartphone processor. The grand vision scales this logic up to solve massive bottlenecks across entire data centers, treating a whole server system as if it were just one single giant chip. Normally, when you scale up, communication between separate chips creates these massive delays. But by introducing what they call the unified bus, engineer/system communication latency from microseconds down to roughly 100 nanoseconds. Guys, that is a mind-bending 500-fold reduction in system lag. And when you add the Hong-1 optical interconnect engine to the mix, the picture gets even more dramatic. While the rest of the tech world is struggling with the power bottlenecks of heavy copper cabling, this system uses light to move data. We're talking 8 terabits per second across distances up to 100 meters. Suddenly, you are powering an isolated, highly efficient AI superbrain using literally the speed of light. So what's next? Section 5, Next Steps to 2031. Where does this all lead? Well, according to internal roadmap notes from May 2026, the trajectory to the end of the decade is just relentless. It signals a complete shift from mere survival to outright global dominance in the semiconductor space. The transition from a 2-layer active structure to a 3-layer stacked architecture is projected to absolutely smash the 5 GHz frequency barrier. But more importantly, it aims to achieve transistor densities of up to 400 million per square millimeter. That is true 1.4 nanometer class equivalence. It's directly challenging the theoretical limits of what traditional fabs even hope to achieve by then. And that brings us to Section 6, a new geopolitical reality. The fascinating and maybe ironic geopolitical reality here is that Western sanctions, which were designed to limit tech access, instead forced an alternative evolution. They essentially provided a national mandate for total self-sufficiency. And you can see the undeniable impact of this shift perfectly captured by Nvidia phone CEO Jensen Huang. He admitted that his company has largely conceded the Chinese AI chip market to Huawei. The restrictions simply forced China to stop buying outside hardware and instead build better, highly integrated localized solutions like the Ascent AI processors. As we wrap up this explainer, I really want you to think critically about this newly engineered reality. If you can't shrink the space, you shrink the time. So is this shift from a geometric yardstick to a temporal yardstick the final nail in the coffin for traditional Moore's Law? Has the global standard for computing permanently changed? Let me know what you think. Make sure to subscribe, hit the bell for more deep dives into the technologies shaping our world, and definitely leave your thoughts on the Tau revolution in the comments below. Thanks so much for watching, and Zaijian.